Welcome to another deep dive. Today we're going to be looking at an essay from Jorgo Schneppat,
Oh, yeah.
and it's about quantum long short-term memory networks,
Okay.
QLSTM. And sometimes I feel like I need a brain upgrade just to keep up with all this information overload these days, and I'm kind of hoping that maybe this QLSTM is what I need.
Well, Schneppat in this essay really lays it out, like how these two cutting-edge fields, quantum computing and AI, are kind of like coming together.
Yeah, before we get into the mind-blowing stuff, can we just quickly recap like how quantum computing works? I know it involves qubits.
Right, so like a regular computer bit, it's either on or off 0 or 1, but a qubit is able to be both at the same time, and that's due to this thing called superposition.
So it's like that analogy of a coin spinning in the air until it lands. It's both heads and tails at the same time.
Exactly. And imagine like millions of coins spinning at the same time. That's the kind of power we're talking about with quantum computing.
Wow. Okay. I'm starting to see why people are so excited about this.
Yeah.
But where does this long short-term memory part fit into it? That sounds like something from brain science.
Yeah, it's actually both. When you're reading a book, you have to remember the earlier chapters to understand what's going on now, right?
Right.
Well, long short-term memory networks, or LSTMs, do the same thing. They give AI that ability to process sequences by remembering earlier data points.
So it's like giving AI a memory boost
Exactly.
to understand things over time.
Exactly. But traditional LSTMs, even with this memory, they still struggle with really large data sets and complex relationships.
So even our fancy AI is hitting a wall.
Exactly.
So is this QLSTM going to come and save the day?
Well, what if instead of using those clunky light switches we talked about, we gave our LSTM those quantum-powered qubits?
Okay.
Right? That's what QLSTM aims to do. It takes the LSTM and adapts it for the quantum level, replaces the traditional operations with quantum gates, which are basically quantum circuits that manipulate these qubits.
Okay, I'm getting the future is now vibes here. But why go through all this trouble? What's the advantage of a QLSTM over a regular LSTM?
Imagine instead of reading one book at a time, you could read an entire library simultaneously.
Okay.
That's the kind of exponential parallelism we're talking about.
Oh, wow.
And it makes traditional LSTMs look like snails.
Okay, speed. I get it, but my computer already overheats if I have like 10 tabs open.
Right.
Is this going to like fry my circuits?
Actually, it's quite the opposite. It can be more efficient because think of it like organizing information in a way that requires less physical memory.
Okay.
Less clutter, less wasted energy.
So we're talking faster processing, less energy use.
Anything else?
This is where it gets really cool.
Yeah.
There's this thing called quantum interference, which allows QLSTM to potentially find connections in data that classical computers would completely miss.
Oh.
It's like finding a hidden corridor in a maze that only a quantum computer can access. That is amazing.
Yep.
We've got this incredibly powerful tool with this incredible potential. But it's not all smooth sailing, right?
Yeah.
What are some of the challenges facing QLSTM?
Well, just like any bleeding edge technology, one of the biggest hurdles is the state of quantum computing itself. Right now, we're limited by the number of qubits we can reliably work with, and they're incredibly sensitive to errors.
So it's like we're trying to build a skyscraper but with like Lego blocks. We need a lot more of them, and they need to be a lot more robust.
Exactly. And of course, building these advanced quantum computers is expensive, which is a big barrier to entry.
Right. So it's not just about the science. It's also about like the resources and the accessibility.
Yeah.
But Schneppat's essay doesn't just focus on the limitations, right?
Mm-hmm.
He also talks about some really exciting real-world applications.
Absolutely. He goes into how QLSTM could revolutionize everything from financial markets to even climate modeling.
Okay, I am hooked.
Yeah.
Let's take a closer look at some of these potential applications when we come back.
Welcome back to our deep dive on quantum long short-term memory networks. And, we have Jorgo Schneppat to thank for this.
Yeah, I'm ready to have my mind blown by these real-world applications. Before the break, we were talking about how QLSTM could revolutionize things like the financial markets. But, how would that actually work?
Well, imagine you're trying to predict the stock market. It's not just about looking at past prices.
Right.
You have to consider news events, economic indicators, even like social media sentiment.
Oh, wow. Yeah, it's like trying to predict the weather, but instead of clouds and wind, it's like tweets and interest rates.
Exactly. Traditional methods struggle to capture all that complexity, but QLSTM could analyze all these data streams simultaneously and spot correlations that humans might miss.
So it's not just crunching numbers faster. It's like seeing the bigger picture.
Yeah.
Like a superpowered financial analyst.
And that's the idea. And Schneppat also talks about climate modeling, which is another field just drowning in complex data.
Right. Trying to predict the climate is like forecasting the stock market, but on a planetary scale.
Precisely. We're talking about massive data sets from satellites, weather stations, ocean currents, all interacting in these incredibly complex ways.
Yeah, even with our best supercomputers, we're still struggling to make accurate long-term climate predictions.
Right.
Is QLSTM really up to the task?
Well, that's what makes it so intriguing. It might be able to cut through that complexity and spot those crucial climate patterns that are currently hidden from us.
Okay, I'm starting to see how powerful this could be. What about something a little closer to home? How could QLSTM change the way we communicate?
Think about language translation.
Okay.
Even the best software right now still trips over nuances like idioms, sarcasm, cultural references, like trying to translate a joke. Sometimes the meaning gets lost in translation.
Oh yeah, I've definitely been there. So QLSTM could help us understand each other better, even across languages and cultures.
That's the potential. It could analyze not just the words themselves, but also the context, the intent, the subtle cues that convey meaning.
Wow, it'd be like having a translator that truly understands what we're trying to say, not just like what the words literally mean.
Exactly.
This is getting me excited about the future of communication.
Yeah, and that future might be closer than you think. Schneepat highlights how QLSTM could revolutionize image and video analysis too,
Okay.
which has huge implications for things like self-driving cars.
Hold on. How does QLSTM apply to, like, driving? I thought that was all about algorithms and sensors and stuff.
Imagine a car navigating a busy city street. It needs to process this constant stream of visual data, making split-second decisions to avoid pedestrians or other cars' obstacles.
Yeah, it's like solving a million tiny puzzles every second just to stay on the road.
Exactly. And QLSTM, with its ability to analyze visual data so quickly and efficiently, could be the key to making self-driving cars safer and more reliable.
So we're not just talking about faster processing, we're talking about like better decision making,
Right.
even in like really complex and unpredictable situations.
Precisely. And Schneepat doesn't stop there. He even explores how QLSTM could unlock scientific breakthroughs in fields like medicine.
Okay, now we're really getting into sci-fi territory. How could QLSTM help us cure diseases?
Think about a complex problem like protein folding.
Okay.
Proteins are these tiny machines that do all sorts of crucial work in our bodies. But if they misfold, it can lead to diseases like Alzheimer's.
So if we could predict how proteins fold, we could potentially design drugs to prevent those diseases.
That's the hope. But simulating protein folding is incredibly difficult. Even our best computers struggle with it.
So where does QLSTM fit into all this?
Well, imagine a computer that could simulate not just one protein, but millions of them, all folding and interacting in real time. That's the kind of power QLSTM could bring to bear.
That would be revolutionary.
Oh.
We could test drug candidates, virtually speed up drug discovery, potentially even cure diseases that are currently untreatable.
It's definitely a tantalizing prospect, but, let's not get too carried away. While Schneepat paints a very compelling picture of QLSTM's potential, he's also very realistic about the challenges.
Right. I know we touched on some of those earlier, but let's dive into those challenges a bit deeper after a short break. Welcome back to the Deep Dive. We've been exploring this really mind-bending concept of quantum long short-term memory networks, or QLSTMs, guided by Yorgo Schneepat's essay. Before break, we were talking about all this amazing potential.
Yeah.
But I know there are also some serious challenges to overcome.
Yeah, as with any groundbreaking technology, we're still in those early stages, and Schneepat's very upfront about the hurdles we need to clear.
So let's talk about those hurdles. What are the biggest things holding QLSTM back right now?
Well, the most obvious one is just the state of quantum computing itself.
Right.
The number of qubits we can work with is still limited, and they're incredibly sensitive to noise and errors.
Yeah.
Even the slightest disturbance can throw off those calculations.
It's like we're trying to do brain surgery with oven mitts on.
Yeah, that's a great analogy. We need a whole new generation of quantum computers.
Yeah.
Ones that are more stable, less error-prone, and capable of handling a much larger number of qubits.
Right. And I imagine those advanced quantum computers are not going to be cheap to build or maintain.
Yeah, you're absolutely right. The cost of developing and accessing this technology is a major obstacle. Right now, it's primarily the domain of, well-funded research institutions and tech giants.
So it's not just about the science, it's also about the resources and making sure this technology is accessible
Right.
to a wider range of researchers and developers.
Mm-hmm.
What about the software side of things? Are there challenges with the algorithms themselves?
Definitely. Developing efficient quantum algorithms for QLSTM is crucial.
Yeah.
We need algorithms that can exploit the unique advantages of quantum computing while minimizing the impact of errors and noise.
So it's a delicate balancing act, like
Yes.
trying to write a symphony that sounds beautiful even when played on a slightly out-of-tune piano.
That's a great way to put it. It's a constant process of refinement and optimization. But Schneepat also talks about a more practical approach in the meantime, and that's hybrid computing.
Okay, what's the idea behind hybrid computing?
It's about pragmatism, combining the best of both worlds. Instead of trying to do everything on a quantum computer, we use classical computers for tasks they excel at and reserve the quantum computer for specific operations where it has a clear advantage.
So it's like having a team of specialists,
Yeah,
each one bringing their own unique skills to the table.
exactly. And this hybrid approach could be key to making QLSTM more practical in the near term, even while we're working on those next generation quantum computers.
Right, bridging that gap between where we are now and that ultimate vision. But even with the challenges, there's this real sense of excitement and optimism surrounding QLSTM. And Schneepat's essay really captures that sense of potential. Where do you see this research heading in the future?
I think we're just at the very beginning of a new era in artificial intelligence. As quantum computing matures and we overcome these hardware and algorithm challenges, QLSTM could become as commonplace as machine learning is today.
Wow, that's a pretty bold prediction.
Hmm.
What are some of the areas where you see QLSTM having the biggest impact?
I think we'll see major breakthroughs in areas like drug discovery materials, science financial modeling,
Right.
fields that deal with massive amounts of data and complex systems.
Right.
QLSTM could give us the tools to simulate those systems with unprecedented accuracy, uncover hidden patterns, and make predictions that are currently impossible.
It's like gaining a whole new level of understanding about the world around us.
Exactly. And I think that's what's so exciting about QLSTM. It's not just about making things faster or more efficient. It's about expanding the limits of what we can even comprehend.
So we've gone on quite a journey today with Jorgo Schneepat's essay. From the basics of quantum computing to the mind-boggling potential of QLSTM and the very real challenges that lie ahead.
It's been really fascinating to explore this intersection of two fields that are already pushing the boundaries of human knowledge.
Absolutely. And it makes you wonder what other amazing discoveries await us as quantum computing and AI continue to evolve.
Right.
It's a future full of possibilities and a little bit of awe. Thanks for taking us on this deep dive, and to our listeners, thanks for joining us. We'll see you next time for another exploration of the most intriguing ideas out there.